Alright, so this is the first session on beginning to actually build the Trackuino. You're going to need to get some surface mount technology or surface mount device, SMD or SMD soldering skills. So they make handy little surface mount device practice kits. So it consists of a pretty simple circuit that uses a lot of components. So I say a simple circuit, but the concept is simple. This one just simply blinks an LED. You can see, hopefully you can see there's lots of little pads on there. So a lot of resistors, a lot of capacitors, an IC chip, a transistor, and an LED, which I think after reading, watching a lot of other YouTube videos makes for a pretty good array of the things that you're going to need to be able to actually solder the Trackuino board in a professional way. So some of the other tools that I've brought out, obviously a decent soldering iron is required. I really like this one. This is probably the minimum I would suggest because it can heat up very quickly. And it can maintain its heat, which means when you put it against a decent sized component, it will not cool off, making it more difficult to solder. Then some other tools that you're going to need are some tweezers. These are actually tweezers that I had in my toolbox. Tomorrow I'll be getting a bigger set that is anti-static for the Arduino build. Then I chose to get both solder paste and flux. Both of these are no clean, but I did also order, which is not here, some alcohol. This is store-bought alcohol. It's 50%. The highest I've seen is 70%. What I ordered was 99.9% rubbing alcohol. So I think the real big problem here is it may not be strong enough, and it has water, right? So we don't want anything corroding the components. Soldering iron tips. So after watching several surface mount technology soldering tip, not tips as in these, as in tips, hints. I originally had thought maybe a fine point pin tip would be good, but it turns out that a lot of people are saying that you might want something a little more flat. So I'm actually using a chisel tip on this one. Hopefully you can see that. But I did buy from Amazon an array of tips with various tips to make it easier. So you can see I've got a whole array that fits my soldering iron. I also went ahead and got an anti-static strap. Not so much for this build, although I'm going to use it to work out the kinks with my process, but just in case. I've done computers since I was 7 years old. Built many, worked in huge server rooms. I've never used an anti-static strap. Very rarely have I ever had a component go bad, and very rarely did I ever suspect that an anti-static strap would have stopped it. So I did also go ahead and buy a magnifying lens here. It also has a nice little LED light here. So I've got my 2x lens on this. We'll see how that works out. One thing to note about these is they do have a focal point. So this one is a little close for me. I would say right about there is where the focal point is. So keep that in mind when you're buying one of these. I think that now maybe a desktop magnifier might have been better, but I don't have one to know, and this is my first time. Chem wipes. Also bought some chem wipes. So you can mix this with rubbing alcohol and wipe off your stuff. All right, so let's see here. If you haven't seen surface mount resistors before, they come in little strips like this. Kind of remind me of the old cap gun paper. They are extremely small. So keep that in mind. If you don't have great eyesight, this may not be something that you can do. All right. Also pulled out some paper plates. These things are not easy to get out of here from what I've watched in the videos, and to get them upright. So the idea that I'm going to start off with is I'm going to use just a bit of solder paste on a pad, and then I'm going to use the tweezers to properly set a component on here, and then I'm going to heat it up with the chisel tip. Some other videos that I saw, people were using reflow ovens. They were even making reflow ovens out of toaster ovens. There are some kits. What I kind of discovered is that you're looking at about $200 in the current market, and you could actually, for a little bit more, like $250, you could buy a commercially made reflow oven that has everything, and you wouldn't have to build it. Personally, I would rather not be tinkering with my tools and building some other stuff. So I would probably buy a reflow oven if I were so inclined, which I may be. All right, so we're gonna flip to a closer view. Wipe this off with a chem wipe and some rubbing alcohol. Again, I just showed you the 70%, but I've got 99.9% coming for the actual Trackuino build. All right, so I'm gonna start out with these resistors along here. I don't have a schematic for this circuit. You know, these cheaper pieces, they just kind of throw them at you, which is fine. I was able to identify the strips, the resistors, by the number of pads with the number of pieces here. So my plan, and I'll just put this in focus of the camera here, is to open this up, dump it out on a plate, and then get each resistor turned over. Then once I've done that, I will put a little dab of solder paste on each side of this pad and add some heat, and we'll see where that gets us. There you go. Digging out the plastic here. Oh, and as you can see, these things are small. Got my tweezers and got my magnifying eyes. Now, might just try shaking this to get them. Yeah, I got a lot of them upright pretty quick. If you've ever reloaded ammunition, primers, you can actually shake them and they'll go all in one direction. But it's the wrong direction, and then you can flip them over. So let's see here. Go ahead and scoot these up so that they're all in. Really hard to do that under the magnifying glass, so let me take that off. There we go. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so let me get you zoomed in here. Get that glare out of here. There we go, that's better. And a little bit of focus on that area. Okay, we're ready to begin. So I now have my solder paste, nice little syringe. And we will put a little dab on this first pad. There we go. Got a little too much out, so I'm gonna take a paper towel. You can see that there's a little too much out. I'll wipe that off. All right, now that I've got it pushed up to the tip, I can control it better. So if you can see that, I've just got a smidge on the tip there, and I'm gonna wipe it on this pad. All right, then I'm gonna put a little more on the other side. Now, from what I was watching, I don't think it's super important that you're super clean with this for two reasons. This is solder mixed in with a flux, so it is gonna go away, and then secondly, we will clean up with the 99.9% rubbing or alcohol and a chem wipe. So I've got this a little crooked. There we go. All right, go ahead and turn my soldering iron on. I've got the temperature set to 750 degrees. It's come up at 300 and it is rising quickly. That's definitely one of the things I like about a nice soldering iron, particularly a digital. You can turn it off in between uses so it's not busy burning itself up. It'll get hot very quickly. And then you can see the temperature. So the melting temperature of solder is 600 degrees, so I figure a nice little buffer. I'm sorry, I'm supposed to be at 650 degrees. There we go. Nice little buffer of 50 degrees should do it for me. So this is a brand new tip. I'm gonna tin it real quick. There we go, nice tin. And I did forget to put on my anti-static strap here. So I'm going to put it on my wrist here, as that is something I will be doing when I'm working with the Trackuino components. All right, here we go, adding a little bit of heat. Oh. All right, so it kind of made a little bit of a point on that solder, what I didn't care for, but that joint. I'm gonna wipe off some of the tin here. All right, that's better. And then I'm gonna come in and I'm gonna hit this side, a little bit of heat, and try to clean up that other side. So I didn't mention it, I do have solder wick, and that may also prove to be useful to clean up some of these joints. If you don't know what solder wick is, looks like a braid of metal, and you can hit it with some heat next to solder and it will absorb the solder. So I feel like one of those sides was pretty good, and the other side may come back and put some solder wick against it just to clean it up, make it look professional. All right. One interesting thing I did notice when people were using reflow ovens, they did not need to be super careful about getting these components on straight when both sides were heated. they actually kind of straightened out themselves, which was interesting. So a little bit of heat. And a little bit of heat. I can touch that side up. All right. So do a couple more of these. And then I'll zoom out so you can watch the whole process, not so zoomed in and narrow focused. Did get a little bit of solder paste between the pads here. Wondering if that would end up leading to a bridged resistor. So I do think I am preferring this tweezer with the bend in it. Now in this kit they did give me just enough resistors to complete the kit. So if you drop one of these and lose it, you will not be able to complete this kit. Oh, stood up on its side. I am actually going to get that solder wick out. I really like the joints that I have done. Alright, so some good old Radio Shack desoldering braid, they call it. So sometimes called braid, sometimes called wick. If you can see there, that's what it looks like. This has been kind of pulled thin. Which may be better here. I guess we're gonna find out. Now, in pretty typical fashion of me, I am tinkering with these a little much, and I probably need to leave well enough alone. Alright, so we will zoom out and give you a bigger view. You can kind of see the process here, and if I do change the process, then we will zoom back in. so I think I'm going to change now from using just doing one pad. I'm going to go ahead and solder paste all the pads. I think that make this process go a little bit faster. Turn my soldering iron off so it's not busy keeping the heat on. Looks like one disadvantage of having put all of these gobs of solder paste down is that I've managed to connect two pads here with solder paste, which will probably be fine because it's going to kind of ball up when you add heat. I'd prefer to try to keep them separate so that I don't have problems. This resistor is flipped over. Boom. So I just took the plate, kind of hit it on the table. Seems to have rectified the situation. Alright, turn the soldering iron back on. Tweezers in the tool spot. I can move the tips out of the way and the braid out of the way. 600 degrees. And now we're at 650. I think it might be helpful to hit it right with the front of the chisel chip to get the heat on there quickly. Now I'm just going to go ahead and do each side here. Side, loosen this up a little bit. Alright, one entire row of resistors done. And I'm going to clean it up with some alcohol here. Take a look at it. I don't think it looks like the most professional job. Nah, you're not going to mistake this for an iPhone. if I thought any of those resistors were bridged together, take a potential or a voltmeter and check, see if they have no resistance, then you'll know you've got a problem. In which case, these small resistors would be easy probably to take off, but you might need a hot air gun to take something off more complicated, like the IC in the middle there. Alright, so I'm going to zoom you in here because while we were doing the resistors, I was thinking that it would be nice to try a little bit different technique on the IC. I did buy some flux, which other people were using just a bead of flux across here, and then using some solder to get those down. So I do think after having done these, I would not be able to get solder paste onto the little pads there. So, alright, so I wasn't recording while I was doing the LED. So we may have missed a good lesson here. On the underside of the LED light here, there is a green line and a green dash coming out. So the dash side is the cathode side, and if you can see the schematic here, the flat side of the schematic component is the cathode. In fact, it even says C here. So your green dash goes here. I used a nice decent gob of solder paste on those pads, and then I made sure that I attacked them straight with the chisel tip very quickly to try to not melt the LED, since the housing is probably plastic. I would imagine it's resistant to some degree. You wouldn't be able to use a reflow oven on it if it couldn't resist some heat. Okay, so at this point I think we've seen all the various pieces, that styles, and a little bit of the challenges I've had, although having watched so many YouTube videos, I was able to come in with the skill set necessary to do this pretty proficiently. None of my resistors are completely straight. So something else I noticed is that not all of my resistors are in the same orientation, although for resistors that wouldn't matter. Kind of OCD on the Trackuino, I will make sure that everything looks like it was put together by a robot. So we'll come back. Hopefully the circuit will be completely built and working. If it's not, I'll be a little upset. I do have all the Trackuino stuff coming in this Friday. So today is Tuesday. Got a few more days. I won't have enough time to get another practice kit here. Most of them are in China. To get this one from California, it took a little longer than I would have liked. All right, we'll be back. Okay, so I've decided to turn the camera back on. These capacitors right here are absolutely itty-bitty. They are basically rectangles, so I'll put my thumb in there so you can kind of get a feel for just how small these really are. Try to get some focus here. There we go. Alright, so they are itty-bitty. They have a tendency to want to stand up on their edge. If you can see in the video, I've already pasted a lot of this, and what I'm finding is that being a little generous with this paste is nice. It allows you to get your tip in there and basically conduct the heat right on to the pad. I'm also finding that I have to hold them in place because they want to stand up on end, and then I'll be surprised if I don't have a couple of these are bridged on the underside. So I'm going to turn my soldering iron back on. And you can probably see from the video I'm using the light on my magnifying eyes. Here. So use the angle tweezers to get it in, and then the straight tweezers so that I can balance myself on the pan vise. Come in here and hit it quickly with the chisel. Oh, this is not that big of a problem. I've had worse problems here. There we go. Ugh. You can see that the pull of the solder when you're pulling the iron away wants to take it with it. So I'm going to clean this generous solder paste here up so that it's not connected between the pads. Although that doesn't seem to matter, it kind of just pulls itself towards the metal piece. We'll try something different here. Get this down with the angle piece here, the angle tweezers, and we'll try holding it in place on its side. I don't think there was enough flux there. No, there certainly wasn't. So we're gonna have to use just a hair more flux. Puppy back down and in place with the straight tweezers. Add a little bit of heat, and there, it's bonded. And then the same thing back here. Alright, next pad looks like it's got plenty of solder paste. Now it is connected with solder paste to the pad next to it, but I'm not going to clean it this time. I'm going to see what happens. I got solder wick. And this thing is so small, it's actually easy to heat up and get off. Not bad, not bad. Alright. Other side. What I'm finding out is if I go back and touch these up, go along the side of the capacitor and then pull out, leaves me with somewhat of a professional looking solder joint. Although I think if we're going to do this beyond the Trackuinos, I think the $200 in a reflow oven would be worth it. The only other thing would be if you were doing large circuit board productions, the way they get this solder paste on here, it appears, is that they use a stencil, kind of like screen printing, and squeegee it on, and then put their components on, and then put it in the reflow oven. Next pad definitely has enough paste. I just basically sunk it into a blotch of paste. Alright, so I am almost done with this. I have just this row left to do. I've learned a lot doing this. So if you're going to do a Trackuino, you don't know how to do surface mount technology, surface mount devices, buy yourself a practice kit. It is well worth it. Buy yourself the magnifying glasses with the light on the top. It's been awesome. Also, one thing I've learned about this soldering paste, I'm going to demonstrate how I'm getting it on the pads. I'm plopping it down. If you've ever watched Krispy Kreme Donut Maker, it's the same technique, right? So I kind of just bloop, bloop on each pad. That seems to get just the right amount in a controlled place. Now originally, at the beginning of all this, I thought that holding the component in place would probably not be a good idea. I'm going to demonstrate these last few resistors. The capacitors taught me that I have to hold them in place. The capacitors wanted to pull away from the board along with the iron, and they just didn't want to stay in place, right? There are just flakes of a component, right? So soldering iron's heated up. I've added a little more heat to the soldering iron. Also, before I begin a session, I'm tinning it real quick, and then I'm shaking off the extra solder, and then wiping it on the wet sponge. Alright, so I am grabbing a hold of the component, getting it on there nice and straight, adding my heat, and quickly getting out of there. Alright, so I don't think that's actually over enough. Straighten that up. Boom. Alright, so that's straight. Quite a bit of blob of solder paste here. Not really a problem. You can see it kind of boiled down to nothing. So what's important here is getting a good connection and getting your component straight. Don't worry about the prettiness. I'm finding out that I just come back and clean things up after the fact. You can see, I think my skills have advanced since the beginning of this video. I'm able to do these pretty quickly, fairly accurately. They're definitely all straighter. I don't know if you'll ever get straight, 100% straight. I don't know, based on looking at reflow oven videos, if a real professional circuit board is 100% straight. I would think not. Now, the difference being is that both sides are heated up at once in the reflow oven, so the components have a chance to kind of walk around and center themselves. That might be the difference. Oh, this one was not done. Look at that, something wasn't right here. Go back and look at the video and see if I skipped that. Too busy talking. Oh. That one I got too hot. Both sides got heated up. Problem with getting both sides heated up on the soldering iron is that it's going to want to pull away with the soldering iron. So I'm just going to come back. I like to touch these up and pull away as I'm done. Seems to make sure that the pad and the component are fully covered. So I'm pressing right up against the component, letting it melt, touch the board, and pull back. I think that really ensures that the component got warm enough and the pad gets hot enough, and you draw the solder over the pad. So just have one last thing left to do, and that is solder in the power. So the ground black wire is going to be on the right side. And actually, that was not the right way to do this. Go ahead, pull it out. I'm going to go ahead and work it down here in the middle, down the bottom. And I will readjust the camera because I don't think you can see. There we go. So using the end here, get some focus. All right. So I'm just going to go ahead and tin this hole. There you go. And I'm going to put this in the hole, then heat it up. Voila. And then go ahead and just put this in. Wanted to fall out. All right, so the practice board is 100% complete. Turn the soldering iron off. Now clean these blobs up. Actually, I'll clean everything up. There's quite a bit of alcohol in this chem wipe. I'm just gonna go ahead and get an initial wipe on it. And then I'm gonna look in my tool chest and see if I have a toothbrush. I saw others working with those temporary brushes. And now I know why, because I actually have temporary brushes in here. So it looks like some of the solder flux is underneath the components, and I'm not really able to get under it. I think having the 99.9% isopropyl alcohol will help, because it'll be stronger to dissolve the solder paste. But we're going to work with what I got right now. Again, for the Arduino project, the actual real Arduino, we will be using everything as best as I can determine is needed and can afford. Alright, so let's zoom out here. Completed circuit board there. Let's see if this thing does what it's supposed to do. So you're going to find out, along with me, if I was successful here or not. And we have a no-go, which is fine, because now that gives us the ability to troubleshoot what's wrong. So I'm going to get my voltmeter out, check these connections, and I'll be back hopefully with a solution. Okay, I've been unsuccessful in making this work. I did realize that there is a website here. I was able to get the schematic. I was able to test every one of these resistors that was in play. Not all of these are part of the circuit, and they are correct values, as well as the capacitors here and the resistors here. These capacitors are not in play. Verified my orientation on the parts that matter. I even put in a different LED, thinking maybe I burned up the LED. I verified all the connections to everything. So the only other possibility is that either I burned up these chips, maybe anti-static or static got them, or you know, maybe they didn't work from the get-go. It's more likely that I did something wrong. So I'm gonna go and see if I can find another practice kit on Amazon or something, maybe prime it over quickly. So this session will continue. I really do want to get a working board before I go hacking up on my expensive Arduino components, or Trackuino.